Hello, my name is Steve Kaufman, and welcome to part 2 of our Go React tutorial. In the last part, we were working on the front end of our to-do application, which gave us all of this code here, a nice React app, and we came up with this nice looking thing here. So what we're going to do in this part is start working on the back end. Okay, first thing to do, I'll just shut down this development server. So we'll put our front end on the back burner for a little bit. So I'm going to cd ... go back to our directory that has both of our front end and our back end in it. And we're just going to go into our back end, which I believe is a completely empty directory right now. And we're just going to do code-r dot, and that's going to reload VS Code in this directory. Okay, great. So we've got our blank backend. If you remember, this backend is going to be a Go application. So there's a few first steps for that. First thing we're going to do is go mod init, and then you have to give it a module name, and that's going to be usually github.com/your GitHub username/your repository name, and you should still follow that naming convention even if you're not actually going to push it to GitHub. So I'll just make mine github.com/steve-kaufman/ and this is going to be to-do app tut/backend. Okay, great. That created our go.mod file. This is important if you want to develop a Go app outside of your Go path, which is the old way of doing it. You'd have to keep all of your projects in whatever your Go path is, where you install your Go libraries, in that source directory there. That's where you'd have to have all of your projects, not wherever you want. So that's what Go mod is for. Now, if you remember from the last episode, where we left off is we want to be able to get our list of to-dos from the back end. So that's all the functionality we're going to introduce in this episode, just getting that list of posts from the back end. And we're going to do it in a way that seems sort of roundabout and overly complicated, but really what we're doing is laying the architectural groundwork. So that it's going to be very extensible and it's going to be easy to add on new features in the future. Obviously, for this little simple application, we know what all the features are and they're not possibly going to change. But for tutorials purposes, I'm going to do it the way that it probably should be done if it were a real application. Okay, so the first thing to do is we're going to be doing this sort of clean architecture type of structure here. So our first folder is going to be use cases. This is going to be our package that sort of orchestrates everything. It knows about where the to-dos are, it knows about where to send them and things like that, but it doesn't know the really specific details. So our use cases don't know what database we're using, they don't know that we're using HTTP, they just know that the to-dos are in a place, and they know that they have to be returned and sent somewhere. So our first use case, we're going to call Get Todos. I'll name this gettodos.go, package use cases. And before we get too far here, before we write our first line of code in Get Todos, we're going to go ahead and create our Get Todos test file. I find that this is a really cool and easy way to get started with the backend, is to just get your use cases out there and start doing test-driven development on those use cases, because that lets you get the main logic out of the way first. Okay, so this is going to be package use cases test, and we're going to do func test get todos, and that's going to take in t testing.t. All right, so what should our first test be for Get Todos? So first we need to think about what our use cases dependencies are. So if we want it to get to-dos, it has to know about some to-do repository, right? So before we try to do anything, we should think about the error cases. So we know that it depends on this to-do repository. And when we query this to-do repository to get to-dos, it's probably going to have an error, or it's going to be able to return an error, right? So we need to think about what to do in that error case. That's usually the best place to start with testing, is to not go straight for what's the ideal working scenario, but what are all of the error cases. Do all of those things first, and then test that you're getting the expected response when everything is successful. Because that's really only one of the several possibilities of what could happen in that function, because there's probably going to be several error cases and only one success case. We're going to sort of define a little mock to-dos repository here. So we'll call it type mock to-dos repo, and it's going to be a struct, and it's going to have a function get all to-dos, and it's going to return a list of to-do objects. And we don't have any to-do object structure yet, so we're going to make another directory called entities, and inside here we'll put todo.go. This is going to be a super simple entity. It's not going to have any functions at all, just a plain data structure. Type to-do struct, and this is going to have the same structure as our TypeScript to-do data type from the last part. If I can remember what that was, I'm just going to check really quick. Okay, so we've got a title, which is a string, a description, which is a string. Since we don't have optional types in Go, we're just going to leave this as not optional, because actually when you define a struct, when you instantiate it in Go, if this is a string and we just don't define it, it's going to set it to an empty string. So it's nice and easy that way. Is completed. Okay, perfect. I'll just get rid of all this then. Oh, and I'm sorry, this should be capital I, so that it's a public field. In Go, public fields have to be capitalized. They cannot be lowercase, otherwise they're not exported. Great. Now that we have that out of the way, we're going to change this to entities.todo. And this can also return an error. So if for whatever reason there's an error, depends totally on what this repository implementation might be. If it's a SQL database implementation, maybe there's an error connecting to the database. I don't know, but there's probably going to be an error somewhere at some point. So this has the potential to return an error. And what we're going to do is, since this is a mock and we want to test what happens in the error case, we're going to return nil, so no list at all. And then an error, we're going to do format.errorf to create an error here. If you're not really familiar with Go errors, I would recommend reading a little bit about that. In Go, there are no exceptions, like in Java or in even JavaScript, they have exceptions now. Or I guess they call them errors, but it's still this throw, try, catch type of thing. In Go, errors are just plain values. Functions just return them. So you have to check if your function returned an error. You don't do try and catch. And there's several ways to create an error. All it is an interface. Any object that has an error method on it that returns a string can be returned as an error. But there's a bunch of helper functions that are good for just creating errors on the fly if you don't need them to be named or anything, which is what we want here. We don't want our use case to care about what kind of error this is right now. We just want to see what happens when we give it any error. So format.errorf is just going to create an error with the given string. We'll just say something went wrong. It's a nice vague error. Okay, So now we have this mock to-dos repo, and that means that we can start calling our use case. I want my use case to not be an object in this scenario. Get to-dos, I think, can just be a pure function. It's not going to take a lot of arguments. Not going to have a lot of dependencies. So we'll just do, we'll say our repo is going to be a new mock to-dos repo. And we'll do use cases dot get to-dos repo and assign that to to-dos error. Okay, now we're getting a red underline here because we don't have that function yet. It doesn't exist, so we'll just go ahead and define it really quick. Get to-dos, and this is going to take in an interface that mock to-dos repo implements. So we're going to make an interface. We'll just make a file called interfaces.go here. Package use cases type to-dos repository interface, and it has a method called get all to-dos, which can return a list of entities.todo or an error. Excellent. So this takes in a to-dos repository, and it's going to spit out entities.todo or an error. Okay, and since we just have to implement it, but we don't want to actually care about the implementation right now, we'll return nil, nil. Test. Great. Okay, so now this function exists. What do we want to test right now? If we're thinking about this as sort of a REST API, although our use cases should not care that we're using HTTP, what we really want to do in this case is censor the error. We don't want our user on the front end to know that something happened with our SQL database. They shouldn't care about that. They should just be told that some internal error happened, right? From a security standpoint, this is good. It's also probably too much information for the front end anyway, even if it was useful in some way. I don't think it would be. Okay, so in this case, we don't care about the to-dos that we get back because we're not expecting any. Well, I suppose we can assert that there are none. We should say if error does not equal use cases dot error internal. We're going to fail our tests. We do that by calling the fatal f method on t. Expected error internal got, and we'll give it our error. And I'll make this a capital E because that's nice. Okay, we get a red underline here. Error internal does not exist. We'll just go ahead and create that. And we'll make a file called errors.go. Package use cases var error internal equals fmt.errorf. Internal error is the message. Okay, and then we'll just get rid of this for now because we don't want that red underline when we're just trying to run our test. Okay, open up the terminal, go into use cases, run go test. Fail. Expected error internal got nil. Okay, how do we make this test pass? Return error internal. Okay, great, we're done. End of the episode. We also wanted to assert, that's right, we also wanted to assert that our to-dos are nil. So if to-dos not equal nil, t.fatalf, expected to-dos to be nil, got, and then we'll print out whatever those to-dos apparently look like. Great. And we'll run that. Still passes. You can see here if we were to return like an empty array of them, then we'd get expected to-dos to be nil, got an empty array. So we'll just undo that. Okay, excellent. So this if condition and then fail the test syntax is really weird if you're coming from a language with asserts. Or like JavaScript, if you use jest, you usually use that expect function. It's a debatable topic in Go. Some people like the verbosity of this, and I think in some cases it works much better than an assert syntax. There's the testify package, which is really popular, that gives you sort of an assert syntax, but you still have to inject the t variable into it in sort of a weird way. I also wrote my own little utility that I like using, which sort of mimics the expect syntax of jest, and I believe it derives from a Ruby testing framework. I'm not sure if that's right, but I'm going to pull that in right now, and you can decide for yourself which syntax you like better. This way is just total vanilla Go, no third-party libraries or anything. But I'm going to say expect equals expectate, which is the name of my little library, dot expect t. This line up here just generates an expect object that we can then make asserts with. So down here, instead of if error not equal use-cases.error internal, fail the test, we're going to write expect error to be use-cases.error internal. And we're getting a little red underline here because this is not in our Go mod file. So we'll just run a go get on it quick. Okay, great. That gets rid of our underline. And we'll just get rid of this then. And instead of to-dos not equal nil, we'll write expect to-dos dot to be nil. Great. And this will do our assertions for us. And I think it looks a heck of a lot neater and more readable, but some people really like just doing if statements. So if that's what you like to do, then you should do that. I'll run the go test. Let's see, we're getting an error here. It's saying that an empty array is not nil, but we return nil. So yeah, I think this is one of the cases where expect does not really work because it's treating both of them as empty interfaces, and I guess the nil sort of gets lost in there sometimes when it's an error or something like that. Like it'll treat a nil list of something as an empty list. I'm not really sure why, so we'll just switch that back to how it was. You can totally use both of them, it doesn't matter. If to-dos not equal nil, t.fatal expected to-dos to be nil. And I'm going to be lazy here and not even print them out. Okay, pass, yay. Time for our next test. So we're going to wrap this here in a t.run, which is like a way to do a subtest. Returns error internal when to-dos repository returns error. And we just do another function in here. It's like callbacks if you're a JavaScript person. Okay. And I think it makes it very readable to just put a little test comment there so that it just doesn't just look like a bunch of functions and indents. You're like, oh, there's a test and there's a test and there's a test. So we'll do another one here. t.run. What other error cases could there be? I don't think there are any for this use case because it's so super simple. We just want it to returns to-dos from to-dos repository. That's going to be our test here. And I'm going to get my expect function back in here. Oops. Expect t. And we'll do our repository as a new. So we need a different kind of mock repository here. I'm going to rename this one to bad to-dos repo because it returns an error. And I'll make another one that's actually a mock to-dos repo. Get all to-dos returns a list of entities.todo or an error. And this one is going to return some dummy to-dos. Var dummy to-dos is a list of entities.todo. Title to-do 1. Description of to-do 1 is completed. True. I'll copy and paste these. We'll make 3 of them. Okay. Yes, that looks like some dummy to-dos to me. We're going to just return dummy to-dos and nil, no error. Great. Repo is a new mock to-dos repo. And we'll do to-dos error is usecases.getTodos repo. We'll just quickly assert that our error is nil. And watch what happens if we run this test here. Uh-oh, it failed. That means that we have to actually use our repository in here to make it pass. So repo.getAllToDos. We don't even care about the to-dos right now. We just want to check if there's an error. If error not equal nil, return nil, error internal, return nil, nil. Excellent. Passes. Now all we have to do is assert that our to-dos, and here with my library use expect to equal instead of expect to be for deep equality, which is what you need when you're comparing arrays or structs. So expect to-dos to equal dummy to-dos. We should just be getting those dummy to-dos sent right back to us. Fail! Unbelievable. Okay. To-dos. Okay, how do you like that? a 70-line test file for a 12-line implementation file. Of course, that's not including the interface and the errors, but still, that's, yeah. So it's a lot of testing, but the tests are very important. If this was something more complex, these tests give us a really good safety net. If we were to change the implementation of this in any way, we could just run our tests to verify that it still works. Okay, now we've got this use case done. How do we actually get it to our front end? We still have to implement our HTTP router, and we have to have some kind of persistence. Maybe we could just use memory. Probably just use memory for now. But yeah, okay. So that, but that is probably going to have to be another episode because it has been about half an hour. So I guess we'll work out all that other stuff next time. See you then.